So now let's talk about our last session in advanced module. So here we're going to talk about the new boundary condition implementations. Okay, so when we want to implement new boundary conditions, first we have to identify most appropriate boundary condition that is available in the release version of OpenFOAM. So what I mean to say is something like this way. Let's go to the area where exactly the boundary condition is coded. So we have to go towards the OpenFOAM area, SRC, then finite volume. Inside the finite volume there is a fields. Inside the fields we have FV patch field. Okay, so inside the FV patch field we will look at the different class of boundary condition like basic, constraint and derived. Okay, so let's say we want to develop our new boundary condition. So what one has to do, they have to identify out of this all the available boundary condition, what is the boundary condition that is most appropriate with our new development. Okay, so that is what one has to identify, the most appropriate boundary conditions from the available existing boundary conditions, and we try to adapt that template and then modify for our own requirement. Okay, so that is how one supposed to do. Before we go towards that, let's look at what exactly we're going to do with this. So inside this particular advanced tutorial 09, we have a code and the run, both the two folder we required. In the code we going to develop all the code, and what we're going to do is we try to develop these three boundary condition. One is the parabolic boundary condition, that is the fully developed velocity profile boundary conditions. Okay, so we know that, let's say we want to look at the fully developed velocity profile inside the flow through a pipe. Okay, so we know these equations. Okay, so where 2 V average is nothing but the Umax into 1 minus small r divided by capital R whole square. Capital R is nothing but the radius of the pipe and small r is the variable. So this is the, so streamwise velocity is just the function of r in when we talk about the fully developed profile. Okay, and then what we do, we try to consider the parabolic profile, but now it is oscillating nature. Okay, so we say this is the parabola. Now parabola is oscillating with respect to this particular functions. Okay, and then we go toward the three-dimensional parabola. So this very simple class of the things we try to explore, but if you want to do that, we first have to understand how to develop a particular template for that. Okay, so now we know that we want to develop this parabola type of the velocity profile. Okay, so that profile, that class of boundary condition, we want to code in the OpenFOAM 3.0x platform. Okay, but if we go towards the SRC folder, finite volume, okay, field, FV patch field and the derived. Okay, we don't have a readily any boundary condition available with respect to that, but if you go toward the form extended 4.0 version, inside that SRC finite volume, okay, and then field and FV patch field and the derived, here we have a very nice similar class of boundary condition available, like look, parabolic velocity profile. Okay, let's try to adapt from this area. Okay, but maybe we require certain modifications because we are adapting this template based on the 4.0 and we want to compile it for the 3.0x. okay, so there is a difference. So let's see. So what one has to do, first one has to copy this particular folder and keep this folder inside the our own area where we want to start coding. So I'm keeping inside the code and let's paste it. Okay, first rename this folder name. So I'm renaming it as a my parabola, my parabolic velocity profile. Okay, so always when you copy whatever or adapt, first modify based on your own new boundary conditions. Okay, so otherwise later on by mistake you can overwrite whatever the existing one. Okay, so don't do that. So that is one thing. Here we have a two file. Now if we want to facilitate the compilation of it, we require the make folder. Okay, so we are adopting that make folder, let's say from this area. Okay, so I will give you the idea what exactly this make folder possesses. Okay, so first let's copy. So make folder always have a two file, one is the file and another is the options. Okay, so options allow you to link the required libraries to compile the our new boundary conditions. Okay, so only one src file include required, that is the finite volume include. If we include this, it facilitate all class of the compilation for our very simple class of boundary conditions. Okay, along with that, if you look at the file, okay, inside the file by default it's supposed to be something like this way. Okay, if you copy the make file, let me show you how you can copy the make file from the existing area as well. Okay, so if you look at here, find out, do you we have a Mac folder here? No. Then let's go one step back. Do we have Mac folder in this area? No. Then again one step back again. Wherever you first identify the Mac folder, okay, so that is this folder, you can copy this folder. Okay, so let me copy and paste at moment here, and then inside this you have this both the files. So look here, in place of one file you will see so many files, but idea is that look, this is the same name what you see here. Okay, so right now we are going to compile with the 1c file. Okay, so what one has to do, we have to give a .c file name. Okay, what we with the help of that we want to compile the our code. So let's copy, delete all these entries from this area. Okay, and then only copy that one name. Okay, so exactly the same thing what we adapted from here. Okay, and here we have to give the our own new library name. So we say parabolic velocity BC is our library name, but we want to modify as a my parabolic, not the previous one. Okay, so I am typing my parabolic. Okay, so that is what we required from this area. So that is exactly one can copy and paste. And now if you look at the options folder, so inside options we don't require this. If you retain this, it's also not going to harm. Okay, so don't worry about that part. So like that way you can create your own template. Okay, so what I did, one more time. So first go to the area from where we want to find out the our most appropriate boundary conditions. So we adapted from this area, let's say this. Now find out what is the nearby make folder you have. So in this particular directory we don't have make folder. Let's come out one step. Do we have make folder? No. Again come out. Do we have? No. Then yes, here we got the make folder. So copy this make folder. Okay, and then modified this make folder such a way that it will facilitate our required files. Okay, so ultimately now let's look at again. So this is the make folder what we adapted from that area, and now if we open these files, what we required just options. In options we require finite volume and the includes. Okay, and here we require the our new library name. Okay, now it is my parabolic velocity fv patch vector field.c, and here is my parabolic velocity as a new name for the boundary conditions. Okay, so now by default it's supposed to go to the form lib bin, but you after compilation you cannot keep your new library in this. It's supposed to go to the user bin. Okay, so don't forget to change whatever the code you compile. You make sure it always have a user flag. Okay, as compared to the form application bin or lib bin. Okay, it's supposed to goes towards the user bin. What is the difference in between user bin and application bin? So let's understand that also. Okay, so let's go to the new folder. So when we talk about, let's say, application bin, it goes towards this area. Okay, sorry, after a platform it goes. If I type this, not a user bin. Okay, so what going to happen after compilation? It try to keep this library, that is what we compile, inside this parent installation. So don't do normally like this way, and not normally, don't do at all this way. Okay, so inside of this we have a two folder. One is lib and the bin. Okay, so library if we have, then it goes in lib bin. If it is application, it goes application bin. Okay, so that is what we have, and all the our compiled applications like simple form, piezo form, ico form, everything is available here, and all the different libraries what we are using, it's come under this. So this is about the uh, exactly the parent installation, but we not supposed to keep there, we supposed to keep it in the user area. So we say user bin. So what, when you type user bin, where this entry goes, so it goes towards our own install area. So that means it, where it goes to home folder, OpenFOAM. In the OpenFOAM, sorry, not in the OpenFOAM, home area, and yeah, sorry, home area, correct, home area, OpenFOAM. In the OpenFOAM, my username is lib ubuntu 3.0x, so it's supposed to go here. Inside this you have a platform, and inside this you have again these two folders. So when you compile, your new compile library supposed to come here. Okay, so that is what it's going to happen. Okay, so let me, I already compiled, so it is available here, but after compilation we will see our library with a name. What is the name supposed to be? This, my parabolic velocity BC. Okay, my parabolic velocity BC is the name for that. Okay, so that is what one supposed to do. Okay, so okay, so what we did, we first add up that particular boundary condition files, and we say my parabolic velocity b velocity, this is the name we want to adapt. So now immediately change the name of the C file and this file as well. Okay, so I am changing based on our folder name, my parabolic velocity. Okay, same way here also, rename it. Okay, so look, I am just renaming this fv patch vector field.h. don't rename it, it is the required name. Okay, so you have to change the name only. Okay, so that is what I did. Now open this both the files. Okay, and inside also you try to replace everywhere this name. Okay, so control H, control V, so find and replace to each and every places. Okay, so we say replace okay, we say case sensitive. Okay, in okay, so in entire document we replace with the our own new name. Okay, for this file as well as here also do the same thing, control H. Okay, so inside of this also we try to control H. Okay, sorry, we have to give a name of this. Okay, so we, and in document everywhere we try to replace the name with my parabolic velocity fv patch as a new name. Okay, now what one has to do now, first after doing all these changes, first make sure it's compiled correctly or not. Okay, so that is the first thing one has to check. Okay, so now how to do the compilation. So go to that folder where we have both the file and Mac folder, open our terminal. Okay, and we adapted this for FE40X, but we want to work for OF3.0X. So let's type OF3.0X. Okay, wclean space dot all. Okay, that is first command, and wmac. Okay, and let's say help to wmac. Okay, so if you look at the help, you have a different option, exe. Okay, lib libso. Okay, so compile dynamically linked library, we require this one at present. Why? Because we don't want to change existing code, we want to compile it as a new library, and that library goes as a add-on to our parent codes. Okay, so what we're going to do, we say it is a libso. Okay, so with this let's try to compile this. Okay, if it's compiled properly, okay, so how we know that it is compiled correctly? So it says my parabolic velocity bc dot so is up to date. Okay, if you don't get this up to date as a output, you understand that something wrong, some error maybe appear. Okay, now look at after compilation where it went inside the OpenFOAM lib ubuntu platform, this point lib, and inside that this so file is went. Okay, so exactly what I telling you, in this area you will see the new library, and then we add up this library and we can go ahead and for do the calculations. Okay, so now our template is ready. Okay, so our template is ready. So now let's try to change appropriately what we required. Okay, so what we required the umax value. Okay, so let's come back to our readme file. Okay, so readme file, what we required umax. Okay, so I'm saying that as a final coding, what we going to do, we say this thing. Okay, we say umax into 1 minus r over r whole square. Okay, so that is what we want to develop, and for that we require the variable as a umax. Okay, same way r is the maximum radius or radius of the pipe, that is again we required. So this goes two things as a variable. So whatever, this is also for a parabolic velocity profile. Okay, but now we're going to change for based on our new equations. Okay, so don't think that it is already available and why we are changing, but I want to show you how exactly you can map the variable based on your requirement. Okay, so in place of maximum value, now we have a umax. Okay, so first in the .c file, okay, if you look at the .c file, we have a declarations of variables and all these things. Okay, so what going to happen, we say num space is the form. Okay, so that is the always in every boundary condition, num space always goes as a form only. Okay, and inside of that num space we have a defining first class. Okay, so class is nothing but the my parabolic velocity fv patch vector class, and inside the class you have a public and the private variables as well as functions. Okay, so what we required certain class of variables. Okay, and this variable we going to read from the boundary condition area. So that is the idea behind that. Okay, so now in place of this umax and the vector n and vector y, okay, so n is the flow direction vector, we have to specify direction of the y coordinate, we have to specify. Okay, so that is what we are reading from this area. Okay, and along with that what we required the diameter of a, or sorry, radius of a pipe. Okay, so I'm modifying these entries. Okay, and along with that we have a certain constructor. So this is the first constructor, is the null constructor. Okay, and why I say null constructor, when we go toward the C file we will try to understand. Okay, so it try to construct the patch and internal fields, then try to define the directories. Okay, and okay, and then we try to initialize the variables and all this. It's everything is belong to the constructors. Okay, so constructor is allow us to construct the required variables and the all the yeah, basically whatever the functions and the variables we are going to use inside the class, we can construct or we can develop with the help of these constructors. That is the idea behind that. Okay, and this is the member functions. Okay, that allow us to extract the values from the reading area. So it is the, when we write max value and it try to return the max value underscore 0, then vector and all these quantities. Okay, and then we have a update coefficient, that is the main area or where we going to code, and then we have to write our important variable. So that is what the write options. Okay, and then we say end of the null space, and inside the null space we constructed one class. Okay, So now go to the C file. So if we go towards the C file, what we look at, we send again the null spells, and inside that we try to develop the constructor. So first is called the null constructor. Why it says null constructor? We try to assign the null value or zero value to each and every variables, okay, and then we specify the pointer for that, okay, and then we specify then we are going to read the our required value from the boundary condition area, okay, and this is just checking, and then we say now evaluate it, okay. So and then we also have another pointer as a constructor, okay, and then we have member functions. So that is the update coefficient. So this is basically our main source code, okay, and all the peripheral thing is just to facilitate this executions, okay. So that is what we required, but here they constructed this particular code in different fashions, but we're going to construct based on our own new requirement, okay. So that is the idea, or based on our understanding we try to develop this code, okay. So what we required new variables. So when we how one can develop the new boundary condition and variables. So first identify the variable that is required. So based on our equation we say we required one variable as a umax, another variable as a capital R, okay. So these two variables we have to feed to our new boundary condition, so that based on that we able to develop our velocity profile at appropriate locations, okay. Let's say we want to go with that way, but if you look at this particular developed code, it is much more flexible as compared to what right now we are developing, okay. But we are developing with the understanding that it is, even though it is a stringent code, but we want to understand how exactly one can take into account this all the variables inside the boundary condition area. So let's first define our required variables. So first variables we say it is a scalar quantity, okay, and we want scalar quantity as a new variable. We say umax, okay. So we say umax is our new variable, and please look at this is the style. So it is always whatever the variable underscore is the map style, so you also follow exactly the same style, okay. Then along with that what we required, we also required another scalar, okay, and this scalar name is capital R, okay. So capital R we are reading as a new variable. So these two things required, okay, and later on we clean whatever we don't require, okay. Right now we add the few variables new, and then we're going to clean it. So we add this 1 and 2 variable. Now after we add in our declaration area, we also have to create its member function, so that we can able to return the value. So it is a scalar, okay. So if it is a scalar, try to add up this from the scalar area, okay. So we say scalar, but now this is not this, we say umax, okay. So that is our return value, and it going to give us the value from the umax underscore variable, okay. Same way we required another variables, we say R, okay, rm I am saying, okay, r mean, because R is the set name, so I am changing the name to rm underscore. So I am changing here, so I must change here mean radius, okay, rm I specify. So in the .h file we have to change at these two locations, okay. So it will first we declare the variable, then we facilitate the its member functions. That is what needed, okay. Then that's it in the .c file, okay. So normally when you create few things, okay, it always good if you immediately try to immediately if you try to compile the code, and if any error is created or what, you try to see, okay. So till now no error, okay. So don't develop code at a time, okay. So develop the code in a small segment, okay. Otherwise later on you will not understand what went wrong, okay. So try to go very slowly, don't be in hurry, okay. So first we only define new two variables, okay, and then we say okay, let's declare its member functions so that we can add up that value inside our code. So we set with the .h file. Now go to the C file. Okay, so in the C file, let's start from the constructor. Okay, so inside the constructor, wherever we have a max value, okay, copy the same line immediately, and we say it is not now max value, we say u max. Later on we remove, okay, whatever not required. First you develop, okay, then we try to clean the code. We require two new variable u mean. Okay, so this 2 is set. Okay, so don't try to create any additional error. Okay, if you forget to type this comma, it show you the error. Okay, so make sure it's perfectly all right. Okay, so, and then again try to add up from this the pointer constructor. So we require the pointer for umax. Okay, same way umax. Okay, same way for r as well. So let's construct pointer for rm. Fine. So we are set with this. Then come back here. Okay, we have to look for this value. So try to exactly copy the same line whatever is available here. So we say we are looking for umax value. Where we are going to look, I will show you later on. Okay, so we say umax value we required with the name of umax. Okay, same way we require the r mean radius value. Okay, so we give the same name as a rm. Okay, so we remember that is the same name. Okay, so we are set by reading. Okay, this we didn't want to change. Okay, now this is the final constructor we required. So let's modify this area as well. Okay, we say umax underscore umax underscore. Okay, same way we required the rm mean radius, let's say. Okay, so we are set with this portion. So till now we are able to create all the constructor. Okay, so constructor is ready. Just try to check any error is not there or what. Okay, fine. So we are until unless you are getting is up to date, we need not to worry. Okay, let's say we forget to type this one comma here. Okay, then if type it gives you the error. Look, even though please understand, okay, even though whatever the error we develop, it is the typo error, but look at what it's suggesting. It's saying few things. It's saying that the bracket is failing, okay, because of so and so reason, but it giving you the line number 109. Okay, so line number 109, it is here. So it's saying that here something is missing. So whatever the line number it showing you, okay, this give you the certain ideas. Okay, so now if we reach to this line number, immediately we supposed to see that here we break the continuity. If we don't give the comma, it is break there. Okay, so that's why it's asking about this particular bracket before that. Okay, so it's saying that there is no continuation, so that bracket is required. That is what it meant to say. Okay, so we are set with that. Now let's try to modify our main area. So what we required, look here what they did, they generate one bb as a new bounding box and of that particular patch. So from where this patch come, so it is something like this way. So we specify the boundary condition with the name my parabolic velocity profile, like we are saying the fixed value, total pressure, zero gradient, cyclic, periodic, that is the type name. Similar line in that same 0 folder in the u velocity u file, we try to say for, let's say, inlet, we say my parabolic velocity. So whatever the place is in the patch, we write the my parabolic velocity. It try to understand that we want to take the all the dimension from that particular patch. Okay, so from that patch they find out the BB, and from the BB they find out the its center based on, if it is assuming it is a symmetric boundary, so based on that they find out, okay, this is the center for our requirement. Okay, and then when you have a center, okay, so then we say we find out the C is the center of each and every face. What is the face, each and every face, what it mean? It means something like this way. So let me go towards application area and first understand few concept, then again we come back here. Okay, what that mean? Okay, so running area, let's say my case parabolic, and here I am giving you one, let's say particular file. Okay, so here we require two terminals. So from here on one terminal we're going to compile the code, and another terminal we try to look at the test case. Okay, so we are here, let's say read the file. So mesh to form, mesh ASCII, correct. Okay, and from here let's look at the only velocity inlet as a patch. Okay, so this is the velocity inlet. Let's say on this velocity inlet we want to specify the our parabolic boundary conditions. Okay, so what going to happen? What going to happen is something like this way. In this folder we go here and we say my parabolic velocity profile. Okay, so that is what we're going to specify in this area. So we say my parabolic velocity profile. Okay, and all other variable later on we look at, but from this area on whatever the page we say my parabolic velocity profile, immediately inside the code our code understand that, okay, we are talking about that inlet patch, and it try to find out for the inlet patch this C, what we are creating this C as a new vector. What it going to give you? C is giving you the face center value. What is the face center value? Here we have 1 2 3 4 5 6 7 8 face, and we require the coordinate of each and every face centered. Okay, so if we look at one face 1, so it face centered is as the center of this, so we require this coordinate to specify our boundary condition. Why we require face center coordinate? Because we are working with the collocated mesh. Okay, and anyway, if it is collocated or stagger or anything, we always specify the boundary condition on the patches at the face center. Okay, so we want to find out this face center coordinate. So for that we adapting this one line. We say vector C, you define one vector, and inside one vector we specifying the CF is nothing but center of the face, and the patch, whatever the patch through which we are specifying this my parabolic boundary conditions. Okay, so from the inlet patch we specify, that means it understand that they have to extract the face centered value for the inlet patch based on that. Okay, so we require this inlet patch. Now for our class of the case, we don't require this bounding box or center. Okay, why I am saying not required? Because we say we are considering that our center, okay, exactly it's supposed to lie within the center of this particular domain. Okay, but in this case it is not happening, so I will going to give you the new mesh file where it is exactly at the our center is exactly at the center of this particular inlet patch. Okay, so this is this file we're not going to use for that. Okay, so what we require, we don't require this, we require, let's say C, we require the cell face center. Okay, so for all our patches at the inlet patch. Okay, so that is what we needed. Now what else we required? So if you know the cell face centered, okay, so cell face centered and from the cell face center we try to create our required new scalar variable. Okay, so this is exactly what they are saying. Calculate the location of 1D coordinate for a parabolic profile. Okay, so on each and every point where we want to specify this parabolic profile, we have to find out the location of the cell centered. Okay, so that is what, based on the this entire patch center, but right now we are fixing that our cell patch center is exactly the mid of this entire domain. Okay, so that is how I gave you the one, I will going to give you one mesh file. Okay, so it going to work like that way. So then we go toward the generalized way. Okay, so if that is the case, we don't require this particular coordinate. Okay, so in case of that, we try to modify our new coordinate. Okay, and we say it is chord. So chord is chord, I say underscore r, small r. So understand that what it means. So this is nothing but we try to generate this r coordinate out of it, and this radius we going to specify from the boundary condition area, like here. Okay, so this we going to specify, and u mean also we going to specify. Okay, so that is u max ultimately. Okay, so later on we going to modify this, because this is not exactly the test case for which we are developing the our new boundary conditions. Okay, so chord r is nothing but this radius we want to specify, we want to take into account. So we say chord r is this one. So and now what we have a this center. Okay, so what we required C center. Okay, and the dot product with the our direction vector. Okay, if we specify this, okay, what it going to give, please understand. Okay, let's say y is our direction. What is the y is direction of the y coordinate. Okay, so this, what this going to give you for each of the face, it going to give you x, y and z coordinate. Okay, because it is in 3D always. So when we say face center, so each face center we have a three coordinate, x, y and z coordinate, but out of that we require only y coordinate, and that is our direction vector. So that direction vector we going to specify something like this way: 0 1 0 in y direction. So we when we take this product, what we going to get it is a scalar quantity. Okay, in terms of only y coordinate. Okay, so we, with the help of that, we are set with the y coordinate. Okay, now we have a y coordinate. We also have a our new variables like u max and r min. So we say u max value underscore 1 minus square of not only chord underscore r divided by rm underscore. What it mean? Exactly same equation what we have here. Okay, so we try to code the similar equations. Okay, so I am writing down here these equations. So u r, okay, this is the operator. Okay, and this n is another vector. What is the n telling you? N give you the flow direction, in which direction we want to specify. That means on the inlet patch, flow is going towards the x direction, so we have to specify the x component of velocity. Okay, like in this case, okay, we require the x component velocity, other both the component goes to 0. So that is how we take into account this direction with the help of this vector. Okay, so that is the idea with that. So this is the vector, this is the our equations. When this equation give you the scalar, but finally we are specifying on the vector, so we generating the vector out of it. So vector n is here we specified as a 1 0 0. So what it going to give you? Only one component, all other two component goes to 0 with the help of this. Okay, so that is what we going to achieve out of this particular equation. So what we did, we constructed first one vector. Inside the vector we fill the cell centered value of each of the faces. Okay, and from the cell centered, what we require, we only require the y coordinate. So we say we take a product with respect to one vector. Okay, so vector product. Okay, and we construct the this r out of it. Okay, and then we already have a rm, that is the mean radius of that particular pipe we specified. Okay, umax we specified, and like that way we are set with this particular equations. Okay, now again let's compile it first. Okay, so compilation we're going to do here. Check if we are getting any error or not. If it says it is up to date, no worry. Okay, and then last portion we have to write all the values. Okay, so here we specifying in place of this one. So look, we require this entire token. So if you don't write it, then restart going to fail. Please understand, this writing of these values is very important. If you don't write this, then if you want to restart, let's say after 100 second or 100 time step or anything, it not going to restart properly. Okay, so whatever the variable we going to use here, all the variable we supposed to write it down. So we say umax is the value. Okay, and variable name we say umax underscore. Okay, so that is what we needed. Same way what we required for rm as well. So we say mean radius, and the variable name we say rm. Okay, so that is how one can write it down, this thing. That is very, very important. Please don't mess up here. If you don't write the required variable, then it will going to give you the error. Okay, so that is very, very important. Now again let's clean it and compile it. Okay, so if it's say up to date, we are set with the boundary condition. Now we generated our required boundary condition, but we have some additional variables, that is we didn't use it. Okay, so let's clean that variable. So what we don't require this max value. Okay, so max value is only one additional variable that is not required. So I am you can comment it or you can delete this entry. Okay, whatever you don't require. So first we clean from this area. Now by mistake you didn't clean from the C file, then check, you will get a lots of error. Why it's saying, it says max value is undefined. Okay, so some error like this way. Okay, so look, max value, okay, does not have any field name max value. That means the in the C file it try to find out the max value, but that max value name is not appear inside the .h file. So whatever the field value you require, you make sure that is available in the .h file. If you don't have that, then it going to give you the error. Okay, it's very simple. So now from this area let's clean the max value. Wherever we have max value, just delete that line. Okay, so this is not required, this is not required. Okay, fine. So I think with this we are set. Let's compile it, and if not give you any error, that means we are set. Okay, till max value in the writing portion is available. Okay, so here, so this entry also supposed to be clean. Okay, so with this, if we set, then we are ready to go with the new boundary conditions. Okay, so how we adapted? First we find out our most relevant boundary conditions. Okay, so we copy that, we rename the .c and .h file both, and then we go to the Mac folder and also modify the file and option both the area. Then we open these both the files, and what we did first, we first rename the new with the help of the new name only, then again compile, and then first we add up the new variables inside the .h file in two area, in this one place and another in the return area. Okay, so at these two place we have to specify the we have to specify these new variables. Okay, and then what we did, we then start developing the constructor for that variables. Okay, in each area, so we develop the new constructor wherever we required. Okay, so constructor is done. Then at the end we try to develop the coefficient. So inside this update coefficient is the main area where we have a exact code. Okay, so we have to modify this. Don't forget to keep that code or new variable inside this writing area as well, and then we compile, and at the end whatever is not needed we try to delete the variables. Okay, so do it very neatly. Okay, so you will not face any difficulty for this. Okay, so now let's try to run this case on a very simple two-dimensional pipe flow applications. Okay,